12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. The lesson is brought to you by the Gauteng Department of Education in collaboration with Cybono Discovery Center. So today we'll look at paper 2 revision. So we'll look at all the topics today that constitute paper 2. So let's first look at the mind map. You know, you're doing mind map in languages, and then this is one of the mind maps in this paper 2. So if you look at the mind map, the analytical geometry there constitute 20 plus minus 25 marks. In other words, grade 11 work and grade 10, the work that we have done in grade 10, work that we have done in grade 11, and the work that we have done in grade 12 in analytical geometry, that constitutes 5 marks. The trigonometry that you have done from grade 10 to the one that you have done up to grade 11. So remember, in grade 12 you do 2D and 3D, but here we're going to be looking at the trigonometry that we have done in grade 10 and grade 11, which has got about plus minus 50 marks. That's a lot of marks. So the Euclidean geometry there is plus minus 40 marks. So the Euclidean geometry that you have done throughout your the previous years there, grade 8, grade 9, grade 10, and grade 11 geometry, plus the grade 12 geometry that we have done this year. So that will constitute about plus minus 40 marks. Then we'll do the circles, angles, and angular movement, which you have done from grade 10, you know, those degrees, changing them to radians, grade 10, grade 11, and there's no work that we have done in grade 12 which falls under the angular movement, but there are still some 15 marks here which we're going to be adding for the measurement. So the measurement will also come in there. So we'll have one question there on measurement that we still need to do. So the whole paper there constitutes 150 marks. So you'll realize that you really need to work very hard to get to a mark that is closer to 150 or 150 out of 150. So your paper on paper 2, it's 150 marks, which you must write in 3 hours. Right. Now let's look at the topics now. Now the first topic, analytical geometry, you'll find it in question 1 and question 2. So in question 1 and question 2, that's where you get your analytical geometry. So that's why we're starting with this topic here. So if you look at that, I've put all the formula in there for the analytical geometry. You can see the formula for the distance. So in other words, you must go and analyze your formula sheet before you write on Monday, so that then you understand which formula is used where. So the first formula there that I have here is the distance formula. So you must understand how do we use the distance formula. We use it when we have 2 points, which is x and y, and the other point be maybe x and y. So if I've got 2 points, you can see if I can call this one x1, x2, y1, y2, then I can substitute all those ones in there. But please make sure that you draw that square root correctly, and the squares must also be there. So all the squares must be there. So you must go and check the formula sheet and try to understand how to get a question that deals with the distance between the 2 points, and then try to work with that formula. The formula for the midpoint is x1 plus x2, because some of you write x1 minus x2, and I don't know where you get that formula, but the formula says plus here. The formula with the minus is this one for the gradient. So don't confuse the midpoint formula and the gradient formula. So check them in your formula sheet. They must be written exactly like they are from the formula sheet into your answer book. We have the inclination, which is the angle. So we're going to use m equals to tan of theta. So the gradient there, so you can see that m stands for that gradient there. So that gradient, if I get the gradient of that line, then I can also get the angle by using that formula. This is the formula for the ellipse. So we write it, your questions are going to come in this way. where you're going to have the x squared over something squared, and then y squared over b squared, and that answer on the other side must always be equals to 1. So that's how you're going to get that, and we'll do questions based on that. Now let's look at some of the questions that I've taken from the past papers. The biggest thing that you need to look at here is the sketch and the information given, and see if the two match. If I go to the information given, in this diagram, A is 6 and 5. So I go to my sketch and I see 6 and 5 as coordinates of A. B is 3 and minus 1. I go to B and then I get 3 and minus 1. The coordinates of C are minus 2 and 3. So there's minus 2 and 3. And they're in their correct quadrants. That's very, very, very important. And theta is an angle of inclination of AB. Can you see? So this line AB there, we have an angle which is an acute angle in the right. Now with the positive x-axis, you see they always state that will be in the positive x-axis. So if the angle was on the other side, it will be in the negative x-axis. Now determine the length of AB. How do I then determine the length of AB? So first I must go to the AB. Here are my points for A, points for B. Then I go to the formula sheet, and the length is the distance. So I go to my formula sheet, the distance formula, copy it correctly, and then substitute correctly. So there the AB will be, so remember it's an AB with a square root sign. That's the first thing that you need to do. Then from there I must put my values. I can either start with A or I can start with B. But if I start with the x of A, I must also start with the y at A. So now let's start. If I start at A, I'll say 6 minus, remember the formula has got a minus, so it's 6 minus this one, which is a 3. This must be squared. Then it will be plus the 5. Remember I started with the 6, so I must start with the 5. So it will be 5 minus into minus 1. Remember the first minus will be for the formula, the second minus it is for the value of the y coordinate. So now, then from here, you take your calculator. Please don't try to, you're not going to get marks for saying 6 minus 3 is 3 and then you say 3 squared. Then you say 5 minus 1 is 6 and then you say 6 squared. You take your calculator, you press the square root, you press open bracket, as it is, 6 minus 3, close bracket, square it, plus, open bracket, 5 minus, open another bracket and say minus 1, close the bracket and close the bracket again. Then you say squared. And in this case, if you do it like this, then you're going to get 3 root 5. That's what you're going to get. So it's very, very important that you know how to use your calculator correctly to get the correct answers. All right. Then this question, obviously, the 1 mark will go for the substitution into the correct formula and 1 mark will go for the answer. So you get only 2 marks here. Yeah? So you don't have to, elongate it and, you write down a lot of steps there and then from there for only 2 marks. So 2 marks means it's 2 or 3 steps that you need to put in there. So you get your 2 marks distance, no problem. You must use your quadratic formula. Okay. Right, in the next question, the question says, in the same question, they say determine the coordinates of M. So M, you are told that M is the midpoint of this. So if M is the midpoint, so you go to your formula sheet, then you go and check which formula is for the midpoint. So the midpoint formula, remember the midpoint formula is M into x1 plus x2 divided by 2, y1 plus y2 divided by 2. And obviously we just need to substitute. So we're using A coordinates and C coordinates. So how do I then substitute that? So I'm going to have M into, remember I'm using this, so if I start with C, so I'll start with -2, but because I'm adding, I can start with any, but please, let's make sure that you know the order. It's -2, it's a plus, remember it's not a minus, plus 6 divided by 2, so I'm done with the x values. So the y values there, it's 3 plus the 5 all over 2. Then from there, my midpoint will be, the coordinates of M now is going to be 4, that will be 2, 8 divided by 2, that will be 4, so that coordinate will be 2 and 4. And I know this is right because this value here of x is positive, that value here of x is positive. So therefore the 2 and the 4 could be correct. If I get a -2, then I know my -2 must be on the other side, so it will not be correct because that will be away from the M, the position of the M there. So M coordinates is -2 and 4. So you'll see that these questions there in question 1, they are using the same diagram that we are given there. So in this case here, I already know this, it's going to be 2 and 4, don't have a problem. The distance of that is 3√5. So it is better if you're working on this, the questions, the answers that you get, you put them on the sketch, so that then in the next question, if they ask you something about that, then you know what to do. The gradient of AB, now we need the gradient of AB. So I go to the formula sheet and check which formula is for the gradient. So the gradient is for this line here. So I need the gradient of that. So how do I get the gradient? The gradient, remember, and we still have learners who are writing wrong formula for the gradient, like x2 minus x1 over, that is not correct. Remember, the gradient is y, changing y over the changing x. So if I have changing y over the changing x on this one, is the y value. Now I'm starting with the y value. So I'm going to say 5 minus into -1. See, I've started with the y values. The x values, I'll start with the 6, because I've started with the 5 there, so it will be 6 minus 3. So I'm going to have 5 minus that, so it will be 6 divided by 3, and the gradient there will be 2. So this is the positive gradient. Remember, this line there is a positive gradient. It's increasing, so positive gradient. If we had that something like this, that will be decreasing. But this one is increasing. I know I'm correct because the gradient is positive, it's increasing. This type of question in question 1.4, that you say you just need to write down the value of the tan of theta. So remember, tan of theta is equals to m, which is the gradient. So the gradient for this line here, because this angle is on this line, is between the x-axis and the line. So meaning that that gradient will be equals to 2. So I'm just completing that. Right. That's all that you're doing. So we're just looking for tan of theta. We're not looking for the value of theta, you're looking for the tan of theta. Why are we doing this? So that you can be able to see the connection between the gradient and the inclination of that line, of that angle, which is between the x-axis and the line. Right. Now look at the next question. The next question now asks you to find the size of theta. Already I know that the tangent of theta is equals to 2. It's equals to the gradient, and the gradient in that case is 2. That's quite easy. Calculator, you go to your calculator, you press shift, tan, you press 2. If you say shift tan 2, then you're going to get the angle. So the angle here is going to be 63.43 degrees. And that is what you're going to get. So the angle that you get there, can you check the angle now? The angle here, it says it's 63.43. So if it's 63.43, does it make sense? Yes, that angle is less than 90 degrees. It makes sense. 63.43 makes sense. But if I get an angle of 120 something, then I know that angle doesn't make sense. So you can see the sketch can help you also to identify which answers are correct or are close to what you need. Okay, so now I know the gradient there is 2. I know this point here is 2 and 4. All right, then I know the length of that line. I know it is 3√5. So now they want the equation of the line. Once I see the word equation of the line, then I know it's a straight line in this case. So the equation of the line is y equals to mx plus c, or y minus y1 equals to m into x minus x1. I know your teachers love this, the y minus y1, because it's easy to use. It takes you directly to the equation. Now in this case, they say the line should be parallel. You can see that's a key word here, parallel to AB. What do I know about parallel? Parallel means that the gradient of line 1 is the same as the gradient of line 2. That's very, very important for you to know. So now they want the line that passes through C, which is parallel to this line. So this line should be parallel to some other line that is passing through that. See? Those two lines are parallel. So if these two lines are parallel, it means that the gradient of this line will be the same as the gradient of that line, because they are parallel. You must know that. The gradient of perpendicular lines, there are two gradients multiplied to -1. So in this case, I already know the gradient. So my gradient here is going to be 2. Now I've got a point here. So I'm going to call this point x1 and y1. So I'll have y minus, what is y1? It's 3. Into x minus, what is x1? It's -2. So that will be -2, bracket there. Then I'm going to have y minus 3 equals to 2x. Minus negative times negative is positive. So I'll have 2 times 2 is 4. Then I'm going to have plus 4. Then bring over the -3. Then y will be equals to 2x plus 7. How do I know I'm right? My y-intercept is 7. This line is passing through there. So that point there can be equals to 7. You see? So I can be able to see whether my answers are correct or not. The gradient of the line is an increasing function, so that gradient is positive. Right. So this question there is, it's work done in grade 11. So these are basic things that you need to understand. All the formulae, you need to understand them. I've used almost all the formulae there. The inclination, the midpoint, the gradient, and the distance. We've used almost all the formulae. So if you know all those formulae, you are able to can do this type of questions. All right. In the diagram, O is the center of the circle. Now this question here is based on grade 12 work that you have done this year. So in the diagram, O is the center of the circle. I love it when O is the center of the circle, because it's quite easy for me to deal with this type of questions. Now, 5, square root of 5 and -5, the square root of 5 is that point P there, it's given there. Right? That point is given. We are told that QRS is a tangent. You must know what a tangent is. There's the line, this is the tangent. It's touching the circle at only one point there, so it is a tangent for sure. What is this? This is the y-intercept of that line. This is the x-intercept of that line. Right. Now this is point P. Now let's say determine the radius of the circle. easy question. Radius of the circle is the distance from here to there. So how do I get it? I know it's on the circle. If it's on the circle, I use the equation x squared plus y squared equals to r squared. Or I can use the distance formula because I know that that coordinate is 0, 0. So I'll say 0 minus that and 0 minus that squared, and then I can get the square root. The easier one will be to use the equation of the circle because it's on the circle. Right, and the equation of the circle has got r, which is the radius. So then I can substitute my x value and my y value. So my x value is square root of 5 or squared, plus the y value is negative 5 root 5 squared equals to r squared. Remember, I'm looking for the radius, I'm not looking for the radius squared. Please. So that I can quickly use my calculator there. Square root of 5 squared is 5. Then from there it's 25 multiplied by 5, it's 125. Plus 5 will give me 130, and that will be 130. But this is not the answer. The answer is radius. So most of the time we don't get these answers, these questions right, because we don't read the question. You must go back and read the question again. After you have given us the answer, you must go back and read the question and see if there's nothing missing. Because if you stop here and it's 2 marks, I'll only give you 1. So make sure that you understand what is required. So here what is required is r, the square root of 130. And that is what is required. Okay, right. The next question here says write down. So if they say write down, you don't have to calculate anything. So I can see that this one, this point here, is a mirror to this point. So in other words, because that line passes through that. In other words, it passes through that. That's a mirror of that. So in other words, if I've got square root of 5 and minus 5 root 5, what will be my point here? My point here will be, so if I take the square root of 5 in this side, can you see it's going to be a negative? So it's going to be negative square root of 5. If I take this value here, and you can see it's a positive value on the other side, so this one will be 5 root of 5, which is a positive. So what is the difference between these two? So can you see the other one was positive in this side, it's positive square root of 5, and it was negative on this side. But now on the second quadrant, the same points, then they change their signs. So the other one will be negative, the other one will be positive. So you just swap the signs there. Didn't swap the values, you swapped the signs. Okay, right. Now determine the equation of QR. Now I know that this one now is negative root 5. The other one is 5 root 5. That's at R. Now I need to find the equation of QS. So the equation of QS, yes, the equation of this line. It's a tangent. What do I know about the line from the tangent, from the center of the circle, the radius, and the tangent? They are perpendicular. So if they are perpendicular, if I know the gradient of this line, then I'll know the gradient of that line. Then I can substitute the point. But now for the exams, we don't have this formula, and this formula is not there in the formula sheet, but I'm going to use it now. So please pay attention. And I know most of you teachers are also using this formula. Please pay attention. So it will be x multiplied by x1. And in the meantime, I want you to do it by using the gradient. But you get the gradient of OR, then you get the gradient of QS, and then substitute into the formula for the straight line. But I'm going to use this formula. So now I'm going to use this point here. My x1 is going to be negative square root of 5. Then I'm going to multiply this by x. My y1 is going to be 5 square root of 5. My r squared, remember my r squared for the circle was 130, so I'm going to use 130. Okay, so I'm going to get negative square root of 5x plus, I want to write it properly, 5 root 5 y equals to 130. Then I'm going to make y the subject of the formula. So I'm going to have 5 root 5 y is equals to, if I transpose this one, then I'll get root 5 x plus 130. Then I'll divide both sides by 5 root 5. Then I'm going to get 5 root 5 over 5 root 5 x plus 130 over 5 root 5. Then in this case, my answer is going to be y equals to, sorry, this one is 5 root 5, sorry. The x must be there. So root 5 and root 5 will cancel out, so I'm going to have 1 over 5x. 5 goes once there, 5 into 130 goes 2 there, and it will go 6 times. So my answer will be plus 26 over root 5. Okay, that is my equation. By using the gradient formula, the perpendicular gradients, and see if you get the same answer. So obviously you're going to say the gradient of OR. After getting the gradient of OR, then you get the gradient of QS, then you substitute that value because you'll be having the gradient of QS. Okay. All right. The other question here, now I know the equation of this line here. So the equation of this line is y equals to 1 over 5x plus 26 over root 5. Now we want to find the coordinates of s, and they say write down. What do I know about x? Remember I wrote it, I said it's the y-intercept. So if it's the y-intercept, means that the x value will be equals to 0. So, and if it's 2 marks, then at least you get 1 out of 2 if you're not sure about the y-intercept. Because the x-intercept on the y-axis, it will be x equals to 0. So what am I going to do there now? I'm going to write s is, the x value is 0, so I must get that mark because it's on the y-axis. The y-intercept is the value of c on there. So I'm going to write 26 over root 5. All right. If I take my calculator and put 26 over root 5 and I say equals to, then the calculator gives me something else. So the calculator is going to give me 26 root 5 over 5. And those two are the same. So whether you write 26 over root 5 or 26 root 5 over 5, this will be the same. Okay, it will be the same. So don't worry about that. So you put it on the calculator and said, what is 26 divided by root 5? And then the calculator has done what we call rationalizing the denominator. You want to make the denominator to be a rational number rather than it becomes an irrational number. Okay, so the calculator is very smart. So it does these things for you. Okay, now the question that comes every year and sometimes we don't get it right is the ellipse. So the ellipse in this case, this one a bit tricky, but not that tricky. So we look at this now, we say the equation given is x squared over b squared, over a squared, and plus y squared over b squared equals to 1. So remember this thing here is b squared. a squared. This thing here is b squared. So I need to find my intercepts. So if I go to x squared, it's equals to a squared. And I put square root of 9. I'm going to get x squared equals to 3. But I need the x value. Remember, this is the x-axis, this is the y-axis. I need the x value. I need this x value. So I'm going to do that. I'm going to get x will be plus or minus square root of 3. So meaning that square root of 3 will be between 1 and 2. So 1,73 I think. So that will be somewhere there, and this one will be somewhere there. Right. So meaning that these are my x values. So if I need my y values, I'll go y squared equals to 16. And then my y will be equals to plus or minus square root of 16. And the square root of 16 will be 4. See? So in this case, I'll have a plus 4 and a minus 4. Then I join all this by not using a ruler, because we're having so many diagrams which are not correct. So I'll join this one here, and then I'll join this one here, and I'll join this one there, and I'll join this one there. Then I have my ellipse, which has got 1 mark for the y-axis, 1 mark for the shape, 1 mark for the x-axis, which is correct. See now, if you put this x to be equals to 3, then you come here and say the square root of 9 is 3. So now I got it. Then from there I put a 3 and a 3. That sketch will never be correct. It will never be correct. So we must make sure that we do it correctly. Okay. All right, done with the trigonometry. With the analytical geometry. Then we go, remember analytical geometry we said is going to be about plus minus 25 marks. So your grade 11 work and your grade 12 work combined gives you about 25 marks. So you must try for more than 20 marks from that question, then you'll be on your way to a distinction. Right. In trigonometry, we have quite a number of things that we need to look at. First of all, in trigonometry, we must look at the ratios. So remember the ratios, your sign, you must go and learn your ratios. You must know that, I know in your schools, your teachers taught you the SOHCAHTOA. Please don't just sing it. You must know what is happening in that SOHCAHTOA. So you must know what is it that you are talking about when you say talking about your SOHCAHTOA. Okay, right. So you must know sine opposite over hypotenuse, cos adjacent over hypotenuse, tangent opposite over adjacent, and you must also know your other three, which is the friends to this one. The cosec, the sec, and the cotangent. Now, in this one, you're having your sine rule. You must know your sine rule. That's about we ask it more almost in question 6, and your area rule also. I'm still baffled by learners who really don't know that the famous one. This is called a famous one. I call it a famous one because that's the most famous number that we always get in trigonometry. The sine squared theta plus cos squared theta. There must be an angle. If there's no angle here, it doesn't mean anything. So it's sine squared theta plus cos squared theta equals to 1. You must know how to also play around with it. That if I put sine squared on one side, I'll have 1 minus cos squared. If I make cos squared the subject of the formula, then I'll have 1 minus sine squared. In all these three, you must play around with them. You must take the other one, move the other one to the other side, move the other one to the other side, and see how what you get. So that then, because these questions are asked also in trigonometry, and they ask it as it is. They can ask you, what do you know about tan squared theta? You see that if I move with that side, tan squared theta will be sec squared theta minus 1, or it can be the sine squared theta over cos squared theta. Okay, so you must know those. They are there in your formula sheet. Please go and learn them. These are your ratios that I was talking about. All these ratios, the SOHCAHTOA thing that I was talking about. Please know them. Please know them. And trigonometry will only work in a triangle. okay, in a triangle. And these ratios that we are defining here, we can only define them in a right-angled triangle. So if there's no right-angled triangle, I cannot use these definitions. Then I must use my sine rule, my cosine rule. Okay, right. In this case here, the reduction formula, please know your reduction formula. The 180 degrees minus, in other words, is all angles that are less than 180 but greater than 90. In this quadrant is all angles that are greater than 270, less than 360. Here is 180 plus, quadrant more than 180 and less than 270. Remember, so in other words, if I reduce this angle by using that, the ratios stay the same. This is radians. So if you see pi in the trigonometry, you must know it's 180 degrees. Also in the circles, angles, and angular movement, now 2 pi there is 360 degrees. Okay, right. Calculator work. Each and every learner must get this. And most of the mistakes that we see is when you need to change the ratio of cosec, the ratio of cot, the ratio of sec into a simpler ratio, sine, cos, and tangent. Learn that, because it's very, very important that you must learn that. You must know how to change your cosec. If I'm given cosec of, then I must change it to 1 over sine. Then I can be able to substitute these values. So in this case here, this one was quite easy, straightforward. Cos 3, y is given as 87 degrees, and then x is given as 43 degrees. Then I just use a calculator here. I just use a calculator as it is. Cos open bracket 3 multiplied by 87 minus 43. Then from there, the answer there again, you must get is negative 0.79. Please do not write degrees here, because this is no longer a degree. This is a value of that. Okay, so please do not write degrees. Okay. Now we look at this type of questions which are always a problem. They are always a problem. Every time when we're marking as teachers, we find that this is always a problem, and I don't understand why, because it's just a simple trigonometric Pythagoras type question, a simple trigonometric ratios. Because once I have that line, what do? I draw my line which is connecting to the x-axis, not to the y-axis, to the x-axis, and I put a 90 there. Then I see these values here is a value of x and a value of y. So meaning that my y is going to be a y value. I don't know what it is. My x is going to be negative 2. So can you see I've got, and this is my angle here. You can put that angle here. I don't know what that angle they've put there. Theta, I can put it there. Because it's this is the angle theta. But this angle here will be 180 minus theta. Okay. So it will be 180 minus theta. If I add it to theta, then I get the whole thing to be 180. So which means that angle here, it's still theta. Okay, right. I know they put it there, but put it there. Now, look at this question now. It's the diagram there. It's given. It's a point. We have already worked with that point. OM is the radius, so the R is already given. This is your X. Can you see you've got X, R, and Y? Then you just use the Pythagoras theorem. The value of y, then I use Pythagoras. We do this in grade 10 and grade 11 also. So we look for that. So we're going to use x squared plus y squared equals to r squared. You have used that formula in analytical geometry, so it must not be a problem. Your x value here is minus 2. Your y value is y. Your r is square root of 13 all squared. So which means that my y value, y squared, is going to be your square root of 13 squared is what? It's 13. 13 minus 4, it's 9. So which gives us y is going plus minus 3. But I can see my y is on the positive side. Okay, in the second quadrant, which is where y is positive. So therefore, I'll choose the one which is positive. So my answer is y is equals to 3. Okay. And then you can then get the value of y, because in this case here, I cannot get the sine of theta, because remember, sine is opposite over hypotenuse. So my opposite was y. I did not know what the value is. Now I know I can do it. So my sine of theta is going to be 3 over square root of 13. All right. The other answer can be 3 root 13 over 3. So sometimes, but they said without the use of a calculator. So let's leave it like that, because this is your opposite side of the angle. That is the hypotenuse. Okay. Right. And it continues to say, determine again 13 cos squared theta minus 3 cot theta. So can you see now, I draw it again here. This value here is x, it's negative 2. My y, I know now it's 3. My r is root 13. First I must write down the ratios. What is the ratio for cos? It will be adjacent over hypotenuse. So my cos is going to be adjacent, which is negative 2, over the hypotenuse, which is square root of 13. Now let me write the cot. What is my cot? So cot, it's actually the opposite of tangent. So first let me get my tangent, and I can just change it around. My tangent here will be opposite. Remember, tangent is TOA. So it's opposite over adjacent. So my opposite is 3. My adjacent is negative 2. So what will be cot? Turn it around. Minus 2 over 3. I'm done. So I go to my question here. 13. What is cos? It's negative 2 over square root of 13. This thing is squared. Can you see the square? Minus 3. What is the cot? Minus 2 over 3. Okay, and then I'm done. And I use my calculator as it is. Then I get to my final answer, of which my final answer will be 6. All right. Okay, now the trig equations are also very important. With the trig equation, the biggest challenge here is the ratio. Is the interval. So we are saying we must start from 0 degrees right round up to 270. We stop here. We're not using any of the 360 minus. So in these 3 quadrants, first they say state in which quadrant does theta lie. So they're guiding you actually to say which reduction formula are you going to use. So if I look at the tan of this thing here over 5, it's a negative. Even if I multiply the 5 across, it still be negative. So which means, where is the tan positive? Negative. This is all sin t. I don't worry about this one. So here all of them are positive. Here the sine is the only one with its cosec which are positive, which means that the tan here will also be positive here. So all others are negative here. All are positive. We can't talk negative in the first. So the first is out. The third is out because we want where the tan is negative. Which one is left? The second quadrant. So here the answer will be second quadrant. Okay? Right. That's 1 mark. So in the second quadrant, which reduction formula am I going to use? 180 degrees minus theta. So actually now I know what I'm going to do. Hence, determine the size of the theta. So which means I'm going to have the tan of x, it's equals to, so I multiply the 5 by minus 1,5, then I'm going to get negative 8,5. Right. So what is my angle? First, I must get what I call my reference angle. So my reference angle in this case will be, so I'll go to shift tan 8,5. Please do not put a negative. So we say, I'm just going to put it there, shift tan, so we are going to get something like this. Then from there you put 8,5. I'm putting it in brackets here. Right. Then the angle that we're going to get will be 83.29. But that angle is in this quadrant. Can you see? We want the angle in the second quadrant. So how do I get my angle? Therefore, x will be 180 minus the reference angle. My reference angle is 83.29. So first I must check where that angle is. That ratio is. And then I think I'll get 96.71 degrees. That is my final answer. You can see this one is a reference angle. It is not my answer. Okay, right. Okay. Now we're going to the reduction formula. You can see now I've grouped this question the way they are in an exam paper. So in exam paper, after the trig equations, you're going to get your reduction formula. We're going to use your reduction formula. First, it will be your calculator work, your Pythagoras type, your trig equations, your reduction formula, and the identities. Then you go to your graphs and your 2D, 3D. Right, in the reduction formula, what does this mean? This table is very, 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 very important. So which means, what am I going to do here? Remember what I said about that? In trigonometry, it's 180 degrees. No problem. Then we go and find all this. Remember, it's all sin positive and cosec positive, right? Here is tan and cot positive, the rest are negative. Here it's cos and sec, the rest are negative. Okay, here are all positive. Now, if I look at the cot 180 minus, can you see cot 180 minus? In the second quadrant, there's no cot here, which means then it becomes negative. So I'm going to write negative cot of theta. I'm reducing. But this whole thing is what? Squared. Multiply by 360 minus it's here. Do we have a sec? Yes. Is it positive? Yes. So I just write it as a positive sec of theta. As simple as that. Get a mark for that, you get a mark for that. Then you divide. Cosec 360, I go to 360. Do I have a cosec here? No, I don't. So it means that it is negative. Right. Then from there I go to tan. 180 minus. Do I have a tan there? No, I don't. So it also becomes negative. Already if you do that, you've got 4 marks. See? Then from here, that one is squared, so it's going to be cot squared of theta. Now, look at this. It's going to be cot squared of theta. But the cot squared of theta can be changed to what? To cos squared of theta over sine squared of theta. Remember tangent of theta, it's sine theta over cos theta, which means that this, if it's cot, then it will be cos theta over sine theta. Then this is multiplied by sec, it's 1 over cos of theta. This whole thing there, it's divided by. So I just want to make life easy for this one, so that we don't have division there, division there. Cosec, it's 1 over sine of theta. Remember, the negative and the negative will give us a positive, but this negative is squared, so it becomes a positive. So everything there is positive. Tangent, it's going to be sine theta over cos of theta. Right. So in this case, cos and cos out in that bracket, sine and sine out in that bracket. What am I left with here? I'm left with cos of theta over sine squared of theta. If I'm multiplying, if I'm dividing, what do? I multiply. This one is 1 over cos. So what does it become? Cos theta over 1. So cos times cos gives us cos squared of theta, all over sine squared times 1, sine squared of theta. And that will give us cot squared of theta. You can leave it there, you can leave it there, it doesn't matter. So you'll get that answer. You'll get the solutions right. Okay. So this question here, once you have done that and changing this, you're going to get a mark. Changing that, I think you're going to get a mark for that. Then from the writing down the answer in that form, you're going to get a mark. So the 4 marks here are crucial. So you must always know this table, and then from the use that table you can do your reduction formula. Okay, right. Same applies to the identities. We're going to use the same thing here, but in this case I don't think that will be that will work here, but please know this table. Okay, in this case here, what do we do? What are we going to be doing here? So first of all, you're going to multiply out what is inside the bracket, but now you must do your left hand side first. Right, the right hand side, I think it's simplified enough. So I'm going to have 1 minus inside the bracket. This is the binomial multiplied by a binomial. So the answer will be sine squared of x minus 2. It's like a minus b. It's all squared. Minus 2ab plus b squared. And done. So the same as a plus b. So you know it's a squared minus 2ab plus b squared. So this is sine squared x minus 2 sine x cos x. It's like ab. This is a squared. This is ab. This is b squared. Okay. Then that is divided by sine of x. Then in this case, these 2 here, you can see these 2, if I add them together, they give me 1. So already I've got my famous one. You get it? So sine squared x plus cos squared x is 1. So it's my famous one. So I'll have 1 minus my famous 1. Negative times negative is positive 2 sine x cos x. This one here is the sine squared plus cos squared x. And that is divided by sine x. 1 minus 1 is 0. I'm left with 2 sine x cos x all over sine x. What cancels out? That. What am I left with? 2 cos x. Is it the same as the right hand side? Yes. I write the right hand side. So the left hand side equals the right hand side. I must prove that. Okay. Don't put equal sign and put 2x throughout. Yeah, 2 cos x throughout. No. You must first do the left hand. If they say proof, you must start with the left hand side. Make sure that what you get on the left hand side equals the right hand side. If you still need to simplify the right hand side, please do so. Okay. All right. Easy stuff. Trigonometry is quite very easy. We really need to work on, especially the Pythagoras type questions. We need to really work on them. The tree graphs, these are tree graphs that we do in our syllabus. Hope those ones you know from grade 10 and grade 11. The question here, you are given f of x, which is your 2 cos x graph. The g of x is sine 2x. This is your interval, where your graph starts and where your graph will end. So you cannot have 0 to 360 graph when you are given that it must start from 0 to 18. And those two values are included. Now write down the range of f. Remember the range, it is where the graph starts on top there, where it starts at on top and where it ends at the bottom. Right, in this case, the range of this graph. So if we look at the F graph here, see there, that graph is going to start at 2 and is going to end somewhere at -2. So which means that our range will be from 2. So I'm going to write my range as -2 y. Remember, my range is y less or equals to 2. I can write this as y. It's an element of the -2, it's included, and 2 it's also included. So this is all. So I can write it in this. So I must know how to write it in both ways. But I must not, in the exam, you must write one of them. Sometimes they might ask you to write it in interval form. So sometimes they can ask you to write it in the other form. Okay. So the period of G. So remember, period, G is this one. The graph is sine 2x. So what is, remember the period for the sine graph. The period for the sine graph and the cos graph is 360 degrees. So if there's a 2 in there, then the period of the graph will be 360 degrees divided by 2. If it was 3 there, it will be divided by 3. If it was half, it will be divided by half. So in this case, the period of the graph, you just write the value 180 degrees. Please do not write intervals, because we see a lot of answers where you write intervals, you write it axis between this and that. And this 180 that is here, it's not the same as that 180 there. This 180 shows that the graph starts from here to there, to 0 to 180. This one tells us about how many of this graph, how many complete graph are we going to have. Right. Now, in this case here, if it was 360 there, then we're going to have 2 graphs in there. Right. Now, but we are ending at 180, so we'll have part of the graph. The amplitude of F, we go back again. Amplitude is that number that is next to that. It must be a positive value. So in this case, it's a 2, so it must be a 2. Okay, these are easy questions that we must quickly answer and then we get it done with. Now, sketch the 2 graphs on the same set of axes. You must show us the turning points of the graph, the endpoints and the intercept. So the endpoint means this is where the graph is going to stop. So first of all, we have the sine graph. So the cos graph, which is an F graph. So I'm going to use the 45, which is somewhere here. So I know at 45 it will be 1, and there it will be 0, and I know it passes at 90. So you can use your calculator to do that. Né? So use a calculator. If you substitute the value of x by 0, by 45, by 90, by that, so you get these values that I'm plotting now. At 135, which is somewhere there, it will be at -1, and then from there we have it at 180 degrees. So I'm going to have this graph drawn from here. It goes to 90, it goes to 130, then it's there. Right, that is my graph. So the other graph, which is 2 cos, so it will start from 2. Remember the cos graph start from 1, but this one, because of that 2, it will start from 2. So it will start from 2, then it goes to 90. I'm just going to put a cross there, and then it goes to -2 there. So I can just draw this graph, rough like that, and rough like that, and the graph will stop there. Right. So this is going to be my G graph. This is going to be my F graph. Okay. Right. So now I've got the 2 graphs here, so that one must be the F and the other one must be the G. Sorry. Right. So now I have my 2 graphs, and you can see that we said the amplitude will be from this to that. So my amplitude is 2. Okay, right. And then what other question did we put in there? I think this graph must also pass at that point there. Right. So what is the other graph? That the period of the graph is 180, and this graph, the range of the graph starts from minus 2 to 2 there. So that's our range of that graph. Okay. Now this is a question that gives us a lot of problems also, but it is very easy. It says P is the top of a pole and its base Q on the same set of axes as these points R and S. The angle of elevation, that's P, is 25. RS is given as 102. This is given as 30. This is given as 40. This is a triangle. Now we need, this is a right angle triangle. I love right angle triangles because I can use the sine and the cos and that. Now we want it to give us the size of RQS. RQS. This is 40. This is 30. For it to make 180, what do we need? 110. As simple as that. And they say write down. You see? So that angle here, RQS, it's 110 degrees. As simple as that. In the next sketch, I know this is 110 degrees. Now look at these questions, quite very easy questions. This asking you RQ over sine S, it's equals to RS over sine that, sine 110. So it will be over sine of RQS. That's all that they're asking you, 1 mark. Now let's look at the next one, this line here, this triangle here. Tan 25, tan is opposite, which is PQ, over RQ. All that they are asking you. Alright, so you just need to understand your sine rule and also understand your trig ratios. Remember, in a right angle triangle, we use the trig ratios. In a non-right angle triangle, we use the sine rule and the cosine rule. Determine the length of PQ. That is a big of a challenge here now. Now we need PQ. Where is PQ? PQ. For me to get PQ, I must use this. But for me to use this one, then I first need to get RQ, which is this one. That is the connection. So meaning that this line is the one that is connecting these two triangles. So if I call it a link, if I can get that link to the other triangle, I'm done. Now, the two questions here, they are guiding you. So in other words, they're saying, for me to get RQ, I can use this one. So I can say RQ over sine of S. I know what is S, it's 30 degrees. And then RS, I know what is RS. RS is 102 over, what is sine of RQS? It's sine of 110. I already know that. Let me see. Then I need RQ. I can make RQ the subject of the formula, which is 102 times sine 30 divided by sine 110. Then I can just quickly use my calculator. I think my calculator will give me 54,27, I think. Right? So that's RQ. So I know this line RQ. So can you see, if I know RQ, I'm able to can use this one to get to PQ. So I can then say tan of 25. This should be 5 marks. I'll give it 5 or 6 marks. So PQ I don't know, but RQ I know it's 54.27. Making PQ the subject of the formula will give me 54,27 multiplied by tan 25. Then the answer there, I think, should be 25.31 meters. So you see, I've answered the question PQ. My PQ is that. Can I be able to get PQ from here? No. If I don't know what is RQ, which is my connecting line to the other one, I will not be able to can get it. Because in this triangle, only one thing is given. Two things, 35 and 90. The other one that I can get is this angle here, which is 65. But the sides, I don't even have one side. So if I give one side, at least I can be able to can work with the ratio. Okay, you can see the trick there. Eh? All right. And what type of equation would that be if they don't ask you about the area of the triangle? The area of the triangle, which triangle am I looking for? This is 110. This is 54.27. Right? So in this triangle, they're looking for the area of that triangle here. In this triangle, what do I need for that? For the area, I need this. I need this side, I need this side, I need this angle which is included. Sign like that. So if I've got this side and that side, are these two sides? Do I have these two sides? Yes. If I take this side and that side, I don't have that one. If I take this side and that side, I don't have that angle, that line. So the only side that is left is this. So it means that my area is going to be half of 54.27 multiplied by 102 multiplied by sine of. So you see I've taken this and that, so the angle that must be there must be 40. Okay, then immediately my calculator gives me, I think 1779.09. Remember, it's in meters. It's very important that you also write your units. It's meters squared. So I must also include those squared. Meters squared. Okay, and that is the area of that triangle. Okay, we're going to take a 2 minutes break and then we'll be back. Okay, welcome back. Now let's get to the Euclidean geometry. Just chosen 2 questions here, which are also very, very, very important. Now in the figure below, O is the center. So if O is the center of that circle EDCF, OE is 7 centimeters. So it's very, very important that you know that OE is a radius, so the radius is 7 centimeters. DF it's 8 centimeters, so DF, the whole of DF, it's 8 centimeters, which means that I know that there's a line from the center of the circle perpendicular to the chord. It bisects the chord. It's even shown, which means that if that whole line is 8, this is 4, that is 4. Okay, right. And these are D, so that is a radius, that is a radius, and that is a radius, and all those ones are going to be 7, 7. Okay, right. Now they say write the diameter, write down the diameter of EC. So the whole line here, from here to there it's 7, from here to there it's 7. So the diameter of that will be 14 centimeters. That's an easy question. Determine the length of EM. So I need E to M. I know E to O it's 7. So I don't know what is O to M. Otherwise, then I will be able to can just quickly add the 2 and then get the length of EM. So it means that I must first calculate OM. Then I can use this triangle. Let me see there. It's a right angle triangle, so I can use the theorem of Pythagoras. So I can then say OM squared equals to OD squared minus DM squared. So what is my OD squared? It's 7. DM squared is 4. So I'll have 49 minus 16. And what is 49 minus 16? So I think that will be 33. So which means that OM will be square root of 33. So this part from here to there, it's square root of 33. So how do I know the length of this? I must add square root of 33 and 7. So which means that my EM will be square root of 33 plus 7. Then I'll get, I think it will be 12,79. You can use your calculator there and put it in decimal form. Okay, so the length of that line here of EM. Always go back to your question and see what is it that they've asked. Did I answer the question? That's very important. Okay, in the diagram, AB it's 30 units, in the second one. So the whole length there is 30 units. AC it's 20 units. The whole length there is 20 units. BC it's 9 units indicated there. And this line here, it's parallel to that line. I love it when the triangle has got two parallel lines there. So I know already, I know that that length over that length is the same as this length over that length. The ratio. Now, I'm given that AD, it's 3K, and DB, it's 2K. So I can just write them like that. So those ones are not lengths, remember. It's 3 of them. Whatever length I have, 3 of them. Right. So how do I determine the length of ABD and DB? Ratios, grade 9. So we go back to the ratios, grade 9. So what do we do? First, remember you must add these values. 3 plus 2 is 5. Right. Then from there I can then say my AD, because it's 3, it will be 3 over 5. It's 3 over the total. Multiply by the 30, which is the 30 units. So I need to find the length of AB. So the length of AD, 5 there goes once, 5 there goes 6 times. So I'll have 18 units. So if this length here is 18 units, do I still need to calculate the BD? I don't think so, because the whole length is 30 minus 18, but we can still determine it by using the ratio. So that then we multiply by 30, and that will be 12 units. So I got the AD and I've got that. So the length of AD, it's that because that was given as the length of AD. It does not mean that the length of this, it's 18 and the length of that, it's 12. No, it doesn't mean that. So this is 12 units. All right. Okay. In the two triangles, they say show that the two are similar. If ACB is 120 degrees. Obviously, if this line is parallel to this line, that angle here will be 120 degrees. Okay, and they're corresponding angles because this line here is parallel to that line that's given. So they say we must show. So three things that we must show. The first one, in this triangle here, ADE, and the bigger triangle ABC, the angle A is a common angle. So I'm going to write angle A, it's common. Right. Number two, I'm given that this angle is 120, and I said this one will also be 120. So which means that angle ACB, it's equals to angle AED, and they're all equals to 120 degrees. So my reason can be corresponding angles. Then from there I must write down lines that are parallel. DE is parallel to BC. If you write corresponding angles or alternate angles, co-interior angles and all, you must write down the parallel lines, the set of parallel lines that you're working with. The third one, I can just immediately say this angle here and that angle will be equal. Those are the only angles that are left here, this one and that one, in the two triangles. So I can just say angle ABC, it's equals to angle ADE. So those two angles are equal. Okay. So I'll just say third angle, I can say corresponding angles also. So they're either corresponding angles or I can just say third angle. Okay, in a triangle. Therefore, triangle ADE, it's similar to triangle. You must prove two angles to be equal. The other one it will be a third angle, it will be obvious. Then from there you must write the reasons, because we need the reasons for similarity, and those are the two reasons for similarity. I mean, these are the reasons for similarity. So here I said we can just say, I'm just going to write third angle. All right, but they are corresponding. You can see this angle and that angle are also corresponding. Okay, the A is common there. So this is a very lovely question, and it's the one that we have seen in class, the teachers doing it. Then please, we must practice these things. Okay. Now the last topic, the circles, angles, and angular movement. I know most of you are getting marks in this one. You just love it. Reason being maybe that the formula sheet at the back of your question paper has got the formula are written. Arc length, they are written. You know, all of them. They've got some explanations there and what to substitute by what. So I think maybe that is the reason. If I say arc length, you just go to your formula sheet, you go and look for the arc length formula and then you write it. So Moses bought a piece of land. I wish I had money to buy this, as shown on the diagram. Now O is the center of the sector, right, with a radius of 100 that's given on the sketch. Moses or I intends to buy put paving on the shaded segment, this segment here, shaded ABC. Calculate the arc length. Calculate the arc length ABC. The arc length here. So we're talking about that arc length here. We call it S, right? Of the sector. So obviously if we call it S, the formula will be S. It's equals to R theta Right. Remember, in circles, angles, and angular movement, angles must be changed to radians. Right. The radius is 100. The angle we are using is 120 degrees. Most of you are leaving the angles as 120 as degrees, and then you're losing marks. And you know how to change this. Remember, the pi must be on top, the degrees. We are eliminating degrees, so the degrees must be at the bottom. Right? Then from there, remember, now I've already changed it. It's now in radians. Then my answer will be 200 over 3 pi, or I can write it as 209,44 meters. So from here to there, it's 200 pi over 3. Okay, right. Now, these are questions that I know they don't come every year, but we really need to understand them and try them in the examination. Now, they say if 33 bricks cover 1 square meter, how many bricks will be needed to cover this segment here? I already know that S is 200 pi over 3. Now, but I just want to cover this part only. So in other words, I need a formula to, the area formula for this. I need the area of this. That's the only part I want to pave. And to get the formula for the area of this, it's a bit of a challenge. But I know the area of the whole. I know the area of the whole because I know the formula for the area of the whole. What is the formula for the area of the whole? Remember, the area of the formula for the whole is RS over 2, the area of the sector. That you know. It's there in the formula sheet. But the problem is that I don't need this. This I don't need. I need to pave only the part there. So it is going to be the area of the whole minus the area of the triangle. And the area of the triangle in this case is going to be OA times OC sine of 120 degrees. That's very, very important that you understand that this is a triangle, and that triangle is not a right angle triangle. Then I must use the area rule that you have used previously, remember. So I'm going to then say, so that area, I'm going to say sine O here because I've not yet substituted. You see, and that's what you do. You substitute some part and then you don't substitute some other parts. So that will be the sine of angle O. Now let's see, what is my RS? So it is going to, the radius is 100. The S, I already got it, so it's 200 pi over 3, all divided by 2 minus OA is 100, OC is 100, and the sine of 120 degrees. Then I can use the calculator to do all this at once. So the answer is going to be 6141, remember, 85 square meters. Now I've got the area of the whole, the area of this part only now. Remember, I've subtracted the area of the triangle. Then, which means that that number, what must I do with that number now? Remember, this is the area of this part. So they say 33 bricks cover only 1 square meter, which means that this area 6141,8, I'm just going to add 0.01 just to get that other extra brick so that I don't run short. So I'm just going to put a 6 here. Then I'm going to say times 30, multiply by 33. So this is going to be the number of bricks I need. See, the number of bricks I need. Then this answer that I'm going to get will be 202681 bricks. Right, I'm going to buy 202,681 bricks for me to cover this area. Remember, it's a big farm, so I need to cover that area there with pave. Then I need this kind of bricks, and these are things that are practical, that every now and then we see them being done. So these are some of the questions that we really need to work on. Remember, as artisans, you're going to be able to can do some of these things. So if you really work on this type of questions, you really understand how to do things in real life. Right. The next question on the same topic. Now you have the picture shown as a flywheel there, and then calculate the angular velocity. So remember, with the angular velocity, it's very, you go to the formula sheet, check the formula for the angular velocity, which is omega. This is not W, it's omega 2 pi n. Then you just substitute 2 pi. Remember, the revolutions is given per minute. We want it per second, radians per second. So it does just divide it by 60. Then you have got your radians per second. Right, so I think the answer is 15 pi radians per second. That's all that you do. 3 marks, 3 simple, straightforward marks. The biggest challenge is there where you're supposed to convert. Circumferential velocity, remember the formula is V equals to pi dn. Right, so same principle, pi, what is the diameter in there? So the radius is 18, so the diameter is going to be 36. And let's multiply by the same thing there, 450 divided by 60, and this will be in meters per second. Remember, that should be that is in centimeters. We need that should be in centimeters per second. Centimeters per second. Right. So now, if it is meters per second, means that the 36 must be divided by remember, from centimeter to meters, it's divided by 100. So we're gonna divide that by 100 if I'm going to for meters per second, or if we want to make it per meters per second as per the question here, so we can make it divided by 100. Then from there, the answer that you're going to get, it will be 2.7 meters per second pi. Right, so because it's supposed to be 270 if I multiply by that, so 270 divided by 100, so therefore we have 2.7 meters per second. Okay. All right. Now, if the chord length is 15 centimeters, what do we do with that? So remember, do we want to find the height? So the formula for the height, remember, is 4x squared minus 4. Please, you must copy this formula as it is in the formula sheet. It is very important. So we need the height. The diameter we have, it's 36. The height we don't know, but we know the x, which is going to be 15, because that is given there. So it's 15 squared equals to 0. Then I have the formula 4x squared minus 144h plus 225 equals to 0. So for you to get the h, remember, you must use your quadratic formula. So it will be minus into minus 144 plus minus the square root of negative 144 squared minus 4 into 225. That is all divided by h. So h, you're going to get two answers, which is going to be 1,64, or the other answer will be h is 34.36. So now if I'm talking about the smaller height there of the flying wheel to the outer ring, will be 1,64. It's very important that you write down the correct answer after getting these two answers. Okay. All right. Now, with measurement, that also deals with these easy questions, straightforward, and it comes every year, and we are messing up with this question. So in this question there we have, write down one equal length in terms of x. So already I know that the whole length is x, but we've got how many pieces? 1, 2, 3, 4 equal parts. So if I want to write it, it will be x divided by 4, and that's what they need here. And obviously the last question, this time nowadays they ask it differently. Then they need the value of x in this case. Determine the value of x. The area of this whole thing is given. So you remember the formula. So I'm going to have a of t, it's equals to a into O1, right? So it's O1 plus the O2, all divided by 2, and then plus, right? Okay, so now I'm going to have sort of O by On. So the last one, obviously, which is going to be O4, and that will be plus O2 plus O3 plus On minus 1. Right. So you know the formula. So that's 2, 2, 2 is the area. The A is not given. Remember, the A that we're having is A is the equal part, so it's x over 4. Then we're going to have 6 plus 10, remember you add this first one and the last one. So it's 10 plus that divided by 2 plus O2. What is O2? It's going to be 8,7. O3, it's going to be 12. And the other one will be the last one, which is 9,3. Then from there, I can add everything that is there. Multiply the 4 that side, I'm going to get 8, 8, 8. So I get the x here. Then I get 3, 8, 1. If I add all those things in there, then I can get the value of x, which is going to be 23.3. So the value of x is 23.3. And if I take 23.3 divided by 4, then I'll get all the equal pieces there. But this is quite an easy, straightforward question that you really need to understand. Nowadays, they give you the area, they want something else in here. So practice all those three. If the area is not given, you are requested to get the area, all the values must be there. If the A is not there, the area must be there, and then you must get all the other values. Sometimes they'll say this value is not there, so you must be able to get it. If the area is given, then the A is given. So 3 types there, so please make sure you practice all of them so that you're not caught with questions that you did not practice. And I'd like to take this opportunity to wish you well in your exams. Please do practice. You've got the whole weekend to practice, and then you will get the marks that you need. We need everyone to pass at very high marks, 80% plus, and you can do it with these papers. Thank you so much.